All right, let's talk about equations of lines. We'll be in chapter 2, starting off here, and then jump back to chapter 1 for the inequalities part. So there's different forms of equations of lines. The first form that we're going to talk about today is one that's called point dash slope form. So this is similar to slope-intercept form. The difference is instead of having the slope and the y-intercept, we've got the slope and one ordered pair or point that's on the line. So it is this form, y minus y1 equals m parentheses x minus x1. The ordered pair that we're dealing with is x1, y1. So it's those are subscripts for the x and the y value from that ordered pair. Okay, this is still the slope that we talked about last week. It's that same rise over run, the change in y over change in x that we dealt with last week. So point slope form can easily be turned into slope intercept form by just taking that equation and solving it for y, and we'll talk about that as we go along here. But we want to look at writing equations in this form given a slope and a point, or just given 2 points out of that. So let's start with one where we're just going to write the equation of the line. In point slope form. With slope of -3 and through -4, 1. Okay, so it gives us the slope and it gives us the ordered pair, x1, y1. That's what we're given out of that. So we know that we can start with point slope form very easily with this. So point slope form, remember, is y minus y1 equals m parentheses x minus x1. So you're going to take those things, the slope and the x1 and the y1, and you're going to just input those into the formula that's there. So we know -3 is going to go in the place of the m. And then this y is always there, and then we subtract the y value from the ordered pair, which was 1. So y minus 1. And then this second, in the parentheses, you're going to have x minus -4. And there is a little bit of simplifying you can do to this. Right here, we got a double negative. Anytime you have a double negative, we know that turns into what? Positive. So we can clean that up just a little bit and say -3 parentheses x plus 4. And then we're going to leave the y minus 1 there. That is the equation of the line in point slope form. That's all there is to that. If you've got the slope and you've got a point, then you can just plug it right into the places. And if there is a double negative, change it to a plus and you're done. That gets you the point slope form of that line. Where it gets a little bit more difficult, but not much, is when you want to do the same thing, but they tell you it goes through -3, 2, and 2, -4. So it gives you 2 ordered pairs instead of telling you the slope. So we're trying to write it in point slope form, so we know we need a slope and we need an ordered pair. Well, we've got plenty of ordered pairs. We've got to take those 2 ordered pairs and find the slope out of that. Remember, slope is y2 minus y1 over x2 minus x1. So we're just plugging in the ordered pairs there to get the slopes of that. So I could take -4 minus 2 over 2 minus -3. So that's the ordered pair 2, -4, the ordered pair -3, 2 is what I've lined up there. And I'm working that out. That'd be -6 over 2 negatives make a positive, so that's going to be 5. So -6 over 5 is the slope. So now we know that this is m, And since we have two different ordered pairs, we can write two different equations for that, and I'll show you both of those. If we use the ordered pair 3, 2 or negative 3, 2, our problem is going to be y minus 2 equals negative 6 over 5 x minus negative 3. So I'm just plugging in that ordered pair and then simplify that a little bit. We got a double negative right there, so that's going to be y minus 2 equals negative 6 over 5. Just putting that slope in the front, and then x plus 3. This would be one correct answer for that problem. But because we had two different ordered pairs at the beginning, that's not the only one that would be the exact same line or same equation. We can rewrite the equation using the ordered pair 2, negative 4. If we do that, we'll have y minus negative 4. The slope is still negative 6 over 5. And then x minus 2. Well, I've got a double negative right there, so I'm going to make that y plus 4. So there are two different equations for the same line, but just using the different ordered pairs, depending on which one you use. So when you see that on the quiz on Canvas, you're going, if they don't have the ordered pairs, using negative 3, 2, you see 2 and 4 in the problem, oh, they use this ordered pair instead of this other one. So you just kind of look at it and see which one they used to get the correct one there. Again, slope's going to go in the front. This is where our slope is. And then this is the x value. This is the y value from the ordered pair. Same thing over here. Slope, x value, y value. You're not going to have to do both of those equations. You're just going to do one of those. If it asks for it in point slope form, look at the answer choices and decide, hey, which order pair are they using? Because they won't mix it up. They'll do one or the other when they're doing that. All right, so let's look at slope intercept form, and we're going to look at how it relates to point slope form and go from there. So slope intercept form, we talked a little bit about it on Thursday of last week. So we're semi-familiar with it. It's the form that we use the most in algebra class as far as linear equations go. We use this form the most, y equals mx plus b, where m is, again, that slope, and b is your y-intercept. I think we wrote it in function notation last week. It's the same thing. It's just f of x instead of y. They're all, I would take either way there. It's absolutely fine. Okay, so slope and y-intercept. So this one, we don't have an ordered pair in that. We've got a slope and a y-intercept. And what the relationship between this and point slope form can be seen by just showing you an example. If we say we want to write the equation that goes through 0, 6 with a slope of negative 2, if I just write that equation in point slope form first, then I would write it y minus 6 equals negative 2 parentheses x minus 0. And then if I take that equation and just solve it for y, get y by itself, then I've got it in slope intercept form. That's the relationship that we can build between point slope form and slope intercept form. So if we do that, I would have to distribute the negative 2 first, which would give me negative 2x. Technically, negative 2 times 0 would be 0. So technically, there's a plus 0 out there. And then y is not quite by itself. I've got the minus 6 here that I need to get rid of. So I'm going to add it. I'm going to add it to the 0 because that would be a like term because they're just plain numbers. And there we get y equals negative 2x plus 6. And there, because y is by itself, we're in slope intercept form. And there's the slope intercept form of that problem. So here we had point slope. But we can take point slope and make slope intercept out of it. And I usually abbreviate that slope INT for slope intercept. Okay, so we can always start with point slope and build our way to slope intercept form out of that. I like doing it that way. It kind of relates the forms together. You may have done it differently in your math classes previous to this one, and I'm fine as long as you're getting the right equation. I'm fine with you doing it another way, but make sure you're getting the right equations out of that. Okay. Let's look at another one that let's say it goes through -4, 1 with slope of -3. Okay. Same idea. We're going to start with point slope form, and we're going to check that and convert it into slope intercept form. So y minus y1, so that'd be y minus the 1 from the ordered pair. Y minus 1. The slope is -3, so I'm going to put that in the front parentheses. And it would be x minus -4, but that's a double negative, so we're going to know that's going to turn into x plus 4. So there's the point slope form for that equation. We want to write that in slope intercept form as well. So we're going to do the work to get y by itself. So we're just going to solve this equation for y by distributing the -3. It'd be -3x minus 12. -3 times +4 is -12. And then we've got y minus 1 over here. We're one step away from getting y by itself. So we're going to move this 1 by addition because they're subtracting it. The opposite of subtraction is addition. That cancels it out there. Hey, y is by itself. That means I've done the right things. And I've got -3x. And then I have -12 plus 1, which would be -11. I've got that equation in slope intercept form now. So we're starting with point slope form, getting slope intercept form. Okay, so it gets you some practice with both forms there out of that. So that's how I like to do it. I'll show you another way to do that just in case it clicks with you better the other way. I'm not opposed to you doing it either way. The other way would be to take slope intercept form and just start with it and plug in the things you know. Well, I know that y is positive 1. The slope is -3, and the x value is -4. And that leaves me the only variable in there is b, and I solve this equation for b. So 1 equals 12 plus b, and then I subtract 12. That's -11 equals b. What that tells me then is that my y-intercept is a -11. So I would write the equation y equals -3x minus 11. That same answer, those go together. They're the exact same answer. It's the exact same amount of work. One way is not quicker than the other. The only difference is with the one on the left, we used point slope form to start with. So it gets us a little extra practice with that. That's one of the reasons I do it that way, is just because it gives my students a little bit more practice with the point slope form that we're not as familiar with. But again, this one we're just plugging in and solving for B. It's the exact same amount of work. No shorter, no quicker. It's the same. So I'm fine with you doing it either way. I don't care. As long as you get your slope intercept form right, it doesn't matter to me which way you get there. Let's look at one where we're taking and writing the equation of the line through -3, +2, and 2, -4. So we've got two ordered pairs here that we're working with, not just a slope and a point. We're working from two ordered pairs. So when we're working from two ordered pairs, if we're going to write the equation of a line, we need the slope to start with. Before we can do anything else, we've got to find the slope. So we're going to take the y2 minus y1, or x2 minus x1. So we're just taking those ordered pairs and plugging them in and finding the slope. So we've got -4 minus 2 over 2 minus negative 3. Working that out. This is the same two ordered pairs that I used on the previous example. So negative 6 over 5 is what we end up with. So this is our slope. This is M. Okay. So now I can take that and pick one of the ordered pairs. It doesn't matter which one I pick. Just pick one of them and use it to find the equation of the line. I'm just gonna pick the first one with the negative 3, 2, just because it's the first one. There's really no good, bad, or ugly to either of them. So let's take point slope form, y minus 2, negative 6 over 5, x minus negative 3 would be x plus 3. So I'm just plugging that in to point slope form to start off with using one of those ordered pairs. The good thing is that no matter which one of them I start with, I should end up with the same equation in slope-intercept form no matter which one I pick. Okay. So then I'm going to distribute. It'll be negative 6 over 5x. And then I've got a fraction times a regular number there. So maybe I want to do that with the calculator there. I didn't have mine open, so give me a second for it to open. And we'll do that multiplication out of that so that we can practice using a calculator a little bit more. All right, so taking negative 6 over 5. So I'm just typing it in as negative 6 divided by 5 times 3. And it gives me a decimal back, but I want a fraction. So I'm going to hit math, enter, get negative 18 over 5. So minus 18 over 5. And on this side, I've got y minus 2. So I want slope-intercept form, not point slope form. So I need to get y by itself. So I'm going to do the next step, which is adding 2 to both sides. Well, 2 is a like term with the 18 over 5. And I'm not going to go through the trouble of finding a common denominator. I've got a calculator. I'm going to use it to help me here. And I'm just going to type negative 18 over 5 plus 2. And again, I'm going to have to convert that back to a fraction. So math, enter. Negative 8 over 5 is what that turns into. So negative 8 over 5. And there I've got y by itself, so that means I'm in slope-intercept form out of that. So no matter which ordered pair that you started with in the point slope form, you would end up with this exact same equation. So that's always a checking place that you can use if you're not sure when you did it with the first ordered pair. Just redo the problem with the other ordered pair, see if you get the same answer. If you don't, then one of two things has happened. You've made an arithmetic error in the first problem that you did or the second problem you did, or you may have made an arithmetic error in both of them. They're not going to match, so that tells you, hey, I've got to go check stuff here and make sure I'm doing it right out of that. So point slope form, get y by itself, you're in slope intercept form. That's the key to this out of that. All right. The next form that we deal with sometimes is called standard form. Okay. Standard form looks like this. AX plus BY equals C. A, B, and C are just not fractions. That's the rule for this, is to get A, B, and C to not be fractions. So standard form is different from the other two forms in that it has X and Y on the same side. Okay, X and Y are on the same side. X is in the front, Y second, and then whatever number it's equal to is on the right. A, B, and C are just numbers, but they're numbers that are not fractions. That's the rule you've got to remember. You can't have decimals or fractions in standard form. Okay, it's not standard form if it has decimals or fractions in it. Now, one of the beautiful things about this is is if you've got an equation that's in maybe slope-intercept form, something that looks like that. That's slope-intercept form. It is super easy to get x back on the other side. And you get it in standard form by doing that. If I just add 3x to both sides, it cancels it out over there, and I've got 3x. That's a positive y, so I'm going to put plus y is equal to 6. And hey, what do you know? We're into standard form there. So if you can get it in slope-intercept form, moving to standard form is usually 1 or maybe 2 steps away, depending on if it's a fraction or not. And we'll look at both of those scenarios here. Okay, so if we've got something that's in standard or in slope-intercept form, we can move it to standard form by just getting the x back on the other side. So it's a really easy thing out of that. We'll actually call that example F, and then we'll do another one like it. Okay. Let's say y equals negative, or let's do positive 5x minus 11. We want to put that into standard form. So go to, change to standard form. Okay. So x and y need to be on the same side for standard form. So I'm going to move this 5x. It's over here with the negative 11. I don't need it there. I need it over there with the y. So it's a positive 5x. So to move it, I'm going to use a minus 5x to get it over there. And that's going to be negative 5x plus y is equal to negative 11. That is standard form. There's nothing else to do to that. That is just because we don't have fractions in front of the x and the y or this number over here, so we're good as far as that rule goes. X and y are on the same side, so that's true as well. One thing that I will caution you about is that you could also have the equation 5x minus y equals 11. What's the relationship between the blue one and the green one here? What's changed? Yeah, the signs on just the 5x, or it's everybody's changed signs, isn't it? They got instead of a negative 5x, I now got a positive 5x. Instead of a positive y, I've got a negative y. Instead of a negative 11, I've got a positive 11. That makes that also standard form. Be able to recognize that if everybody's sign changed, it's okay. That when you work this from slope-intercept form back into standard form, that you may get negative 5x plus y equals negative 11, but that may not be an answer choice. Your answer choice might be swap the signs of everybody. They are exactly the same equation, though, because if you got the blue one in slope-intercept form, you get 5x minus 11. If you got the green one in slope-intercept form, you'd still get positive 5x minus 11 if you solved it back for y. They are equivalent expressions or equivalent equations because the signs are completely, everybody's the opposite. If only part of it is the opposite, then that's not true. It's got to be everybody out of that. So you got to look out for that. All right, let's look at one that's in slope-intercept form. We want to put y equals negative 6 over 5x minus 8 over 5 in standard form. So we want to take this equation that's in slope-intercept form, and we want to rewrite it into standard form. So not as easy as the last couple have been, but not incredibly difficult either, because again, standard form has x and y on the same side. So my first step is always going to be move the x part to the other side. So this is a negative 6 over 5x. So to move it, I'm going to use a plus 6 over 5x. Okay, so that gets us 6 over 5x plus y is equal to negative 8 over 5. Now, the only other rule for standard form is you can't have fractions in the problem. So we've got to look at these, and I've got two different fractions. I got a 6/5 and a -8/5, and I've got to figure out how to get rid of those. So the way to know how to get rid of those is look at the denominator of the fractions. Both of them happen to have a 5 on the bottom. So to get rid of the fractions, you're going to multiply by that denominator 5. Everybody gets multiplied by 5. So 5 times 6/5, 5 times 1, 5 times -8/5. So that's going to convert it over. So if I take 5 times 6/5, I should get 6. Okay. So I have 6x. 5 times y is the 5y. 5 times -8/5. 5 times -8/5. -8. Now I have an equation that doesn't have any fractions in it. So if I've got a denominator, I need to multiply by that denominator to get rid of the fractions. If it's two different denominators, multiply the two denominators together, and then multiply by each denominator individually will work too. Okay, so if you had a 3 over here and a 5 over here, I'd multiply by 3 and then turn around and multiply by 5, and it will get rid of the fractions for you. Okay, so kind of the culminating idea here with this particular section is to take two ordered pairs and write it in all three forms. So if we got an equation, sorry, my wife just sent me a text. She took her boys to get haircuts today, and they're cutting it all off for some. It's a big pile of hair on the floor. It's so funny. Weird text messages. So let's take through, and I'm going to give you two ordered pairs, and we're going to write it in all three different forms out of this. So we get the practice of starting with point slope form and working our way through till we get to standard form. So the ordered pairs are 1, 1, and let's do 2, 4. Okay. So a couple of small ordered pairs, no negative signs in this one. Makes it easier to do there. You don't have to worry about double negatives. So we're going to start with point slope form. Point slope, easy to do because you got to find the slope first, no matter what. So once we find the slope here, we won't have to redo it when we go to do slope intercept form. It's going to be the same. So I'm going to take my y value, 4 minus 1, 2 minus 1. So that's going to be 3 over 1, which is just 3. So that's nice. My slope is just 3 over 1, just regular 3. So I don't have a fraction to deal with there. And then I take my point slope form. Remember, it's y minus y1, m parentheses x minus x1. So I need to pick an ordered pair to put in point slope form. I'm going to pick the easiest one. I can't screw this one up. 1, 1 is a good one because I can't, it doesn't matter which one it's 1 for y and it's 1 for x. So I can do that. Y minus 1 equals 3 parentheses x minus 1. There are no double negatives to fix. So, hey, I'm done. That's point slope form. If I had done it with the other ordered pair, we'll put that underneath here. Y minus 4 equals 3, x minus 2. Both of those are correct. I picked the easier one, and that's the one I'm going to work with to find slope intercept form and standard form from. But again, you just want to pick the one that's easiest. It doesn't matter which one. They're both options out of that. Okay. So there's point slope form. Let's go over here and let's do slope intercept form from the same problem. Because I've already written the answer in point slope form, I'm just going to start with that. Y minus 1 equals 3 parentheses x minus 1. And to get it in slope intercept form, all I've got to do is get y by itself. So I'm going to do the work of solving that equation for y. So 3 times x and 3 times -1. So that'd be 3x minus 3. That's easy. And now I'm one step away from getting it in slope-intercept form because I just got to get rid of this -1 here. And the way to get rid of that is the +1. 3x minus 2. -3 plus 1 is positive, or it's -2. 3x minus 2 is what I get for my slope-intercept form. Okay. If I had used this green equation here, I'd get the exact same answer. Okay. I'd get y equals 3x minus 2 for slope-intercept form. Standard form. Standard form is taking slope-intercept form and getting x and y on the same side. So I've already got slope-intercept form. So I'm going to take y equals 3x minus 2, and I'm going to manipulate it to get in standard form. Well, that's pretty easy to do. All I've got to do is move this 3x to get the x and the y on the same side. So that's always going to be your first step for standard form is if you've got slope-intercept form, move the x. Okay, so I do that. I get -3x plus y equals -2. Then I look to see if there are any fractions. Well, there's not a fraction here. There's not a fraction here. There's not a fraction here. I'm done. That's standard form. What would be another standard form that could be the correct answer? Standard form is the only one we really have to worry about this on. Remember, what can happen and it be an equivalent equation or the exact same equation just looks different. Change the signs. You got to change it of everybody. So that'd be 3x minus y equals +2. Those are both the standard form for that particular linear equation. Okay? Standard form is the only one you've really got to worry about that on, the sign change idea. Okay. All right. Last thing in this particular section is talking about parallel and perpendicular lines. Okay. So it's still writing equations of lines, but we're going to talk about, let's do parallel first, because that's the one we're most familiar with. What do we know about parallel lines from years of mathematics classes? We know anything about parallel lines. Lines are parallel. They never do what? They never touch. That's what parallel lines do. Okay. They never intersect. It would be the, I guess, the way, but touch is absolutely the idea. They never touch one another. When we talk about their equations, they have the same slope. They have the same slope but different y-intercepts. Okay. The key here is the same slope idea. Okay, because if they have the same slope, then that means I can use the slope to write my equation of a line. Okay, so we're going to be writing equations of lines that are parallel to other lines. So let's take, for example, write the equation of a line parallel to 2x plus 5y equals 4 that goes through 3, 5. So this is taking everything that we just talked about with equations of lines and saying, okay, now I'm going to give you the equation of a line, And I want you to write another equation that has the same slope because it says parallel, same slope, and goes through a different point. Okay, so we want to write an equation of a line that's parallel to that. Well, the only problem that I'm running into here is that my equation that they gave me, I don't have the slope for that. So how can I find the slope of this equation, 2x plus 5y equals 4? Well, that's in standard form. And lights went out on you and Ripley. Too still this morning. 2x plus 5y is equal to 4. That's standard form. If I get that into slope-intercept form, the slope's going to be in front of the x, right? So if I just get y by itself, I'll be able to get the slope out of that. So I'm going to take that equation. I'm going to subtract 2x. So that'd give me 5y equals negative 2x plus 4. So I've taken that equation and moved the x over. The last thing is get rid of the number in front of the y to get y by itself. So we're getting that equation into slope-intercept form from standard form. And we did that a little bit last Thursday when we were talking about literal equations. That's what we were doing. So we're taking, and we're going to divide by 5. So everybody gets divided by 5. We get this fraction, negative 2/5 x plus 4/5. The part that I need, the only part of that equation that I need is that slope that's highlighted there, that negative 2/5. That's the slope that I need. It says parallel, so I'm going to use the exact same slope. Okay, and I want to write that equation for a line parallel to a line that has a slope of negative 2/5 that goes through 3/5. So I'm going to do all the same things that I did on the last equation. I'm going to write it in point slope form. Point slope form, not stope. Point slope form. So I'm going to take y minus y1 equals m parentheses x minus x1. So that's point slope form. I'm going to plug in the stuff I know. I know the slope is negative 2/5. I know the y value is 5, so y minus 5. And I know the x value is 3, so x minus 3. So that's that ordered pair that's up here, the 3 and the 5 there. 3, 5, 3, 5. The slope's negative 2/5, just like I found here. So there's point slope form. So if they ask for it in point slope form, that's it. But, well, maybe they didn't ask for it in point slope form. Maybe they asked for it in slope-intercept form. So I've got to do a little bit of work here. To get it in slope-intercept form, I'm going to take my point slope form, and I'm going to distribute the slope to the x and the minus 3. So that'd be negative 2/5 x, and then plus something. I don't know what 2/5 times 3 is. So negative 2/5 times negative 3. Positive 1.2, math, enter, 6/5. So I'm just using my calculator there to help me do that math. And now I need to get y by itself to get slope-intercept form. I'm going to add 5 to the 6/5. So 6/5 plus 5. And then, again, it gives me a decimal. I want it as fraction, math, enter. 31/5. Y is equal to negative 2/5 x plus 31/5. There's slope-intercept form for that problem. Well, maybe they asked for it in slope-intercept form. Maybe they didn't. Maybe they really wanted us to put it in standard form. So standard form for that. Let's take that slope-intercept form problem. And get x and y on the same side. So my first step would be add 2/5 x. So add the x back or move the x over to the other side. So that's 2/5 x plus y is equal to 31 over 5. Well, the only other rule for standard form is that you can't have fractions in there. So if we don't have fractions, then we've got to take care of the fractions by multiplying by that denominator that's there. They happen to have the same denominator, so all I've got to do is multiply by the 5, and everybody gets multiplied by 5. So that's going to convert it over to standard form. So 2/5 times 5 is 2. 2x. 5 times y would be 5y. That's the easy one. And then 31 over 5 times 5. 31. And there I'm in standard form for that. So no matter which form they ask for, if it's parallel, you're going to start with the slope of the line, and it's going to be the same. Parallels have the same slope. Got to keep that in mind. Parallel lines have the same slope. Okay. So writing the equation of the line, though, is no different. All the steps are the same as far as that goes. All right. Last thing in this section is perpendicular lines. Perpendicular. What do we know about perpendicular lines? It's one we don't do as much with, but it's something we've worked with before, hopefully. Well, they're kind of the opposite of parallel. They do touch. They intersect. They intersect at 90-degree angles. So when two lines that are perpendicular cross, that line, maybe this red one here, they're crossing at 90 degrees. That's what's special about perpendicular. A lot of lines that intersect, but perpendicular lines intersect at that 90-degree angle, which is an important thing as far as geometry goes. So intersecting at 90-degree angles, and the slopes are not the same. They can't be the same because parallel lines have the same slope. Slopes are what's called opposite reciprocals. Fancy words for flip and change the sign. Okay? Flip and change the sign. That's what opposite reciprocal means. Flip the slope over, change its sign. So if it's negative, flip it, make it positive. If it's positive, flip it, make it negative. Okay? Perpendicular lines. They're going to say the words perpendicular when they ask you to do this. They're going to say, write the equation of a line that's perpendicular to this one through this point. So I'm going to write, let's do an example of that. K, example K here. Write the equation of the line perpendicular to 2x plus 5y equals 8. It goes through 3, 5. And let's write it in slope-intercept form. All right, so first thing we need to do is take the equation that they gave us and get the slope off of it, okay, so that we can flip it and change the sign. Okay, so I'm going to get that equation, 2x plus 5y equals 8. I'm going to get y by itself because that makes it easy to find the slope. So I'm going to subtract 2x So that gives me what 5y equals negative 2x plus 8. And then our last step would be divided by 5. All right, so the slope of that line is negative 2/5. The perpendicular slope, that's what we need. The perpendicular slope is take that and flip it over and change the sign. So if I flip it over, it's going to be 5/2, and instead of negative, it's going to be positive 5/2. So this is the perpendicular slope. This is the one we need to use to write the equation of that line. Okay? So we're going to start with the ordered pair and the slope, which technically is point slope form. And then we're going to go to slope intercept form and stop because that's the form they ask us to go to. So y minus y1 m parentheses x minus x1. So we're plugging in the stuff we know. We know the y value is 5, so y minus 5. We know the slope that we're going to use is this perpendicular slope, the 5/2. And then our x value would be x minus 3. Okay, there's point slope form. But I want to get that into slope intercept form. So I'm going to take that 5/2 and I'm going to distribute it. 5/2x and then 5/2 times negative 3. Math, enter. Negative 15/2 minus 15/2. Then I'm going to get y by itself. One step and we're in the slope intercept form. So I'm going to add 5. That's 5/2x, and then I just need to work this out. So negative 15/2 plus 5. Math, enter. Negative 5/2, so minus 5/2. There, we're in slope intercept form for that problem. Okay. So taking an equation and finding the slope, flip it and change the sign to get perpendicular. If it says parallel, just take the slope just as it is and work it. If it says perpendicular, flip it and change the sign. So always looking for that word perpendicular that tells you to flip and change the sign. Any other time, it's just straightforward, use the same slope. Okay? All right. That is writing equations of lines. That finishes up the equations of lines part. Let's get the solving inequalities, and then we'll take a break after we finish solving inequalities. This won't take near as long. This is much easier. 1, 2, 3, 4, 5. 5 examples here, and then we'll take a short break. All right. Paper here. This is actually going back to chapter 1, and we're talking about solving inequalities. Probably the easiest thing we'll do today. All right, so we're going to write our solutions as a graph, and then in set notation and interval notation as well. So we'll do all of those different ways of writing the answer, because it kind of, this textbook tends to mix it up on what kind of answer they want you to write out of this. But the solving part's the easiest part. Okay, so real easy thing here. 3x plus 7 is greater than 13. So all we're asked to do is solve this, and then we're going to get the answers. We're going to do it in all those three forms there. So all we got to do is get x by itself. So real easy stuff here. Let's get rid of the 7 by subtraction. 3x is greater than That'd be 6 divided by 3. X is greater than 2. Remember that there's a rule of it. If you divide by or multiply by a negative when you're solving an inequality, you have to flip the symbol. Here we divided by 3. That doesn't mean we flip the symbol, okay? It has to be a negative that we divide by or multiply by to flip the symbol. So that's going to stay the same. Once you've solved it, if the variable's on the left, the set notation is super easy. The set notation, you're just going to build it around that inequality that you found. X, the straight up and down bar, your inequality that you got at the end, and then curly brace at the end. That's set notation. So if it asks for the answer in set notation, this is what it looks like. Interval notation is the one that uses the brackets and the infinity symbols and those things, all right? And the interval notation and the graph are really closely related. So I like to do those together, okay? And you don't have to have a very long number line here. Just the number line is all we're going to do here. You don't have to have a huge one. Just I made mine a little longer than I probably needed it. But so on this number line, we're looking at what the inequality says. It says that the answers are all the x's that are bigger than 2. That's what that says. X is greater than 2. So I know that somewhere on my number line, I'm going to have a 2, and I'm going to have some numbers that are bigger than 2. So I'm just going to put a few numbers here, and then I'm going to put some that, not -1, but 1 and 0. That's a good one. All right. Now, on your graph, the interval notation relates to that. So it's all the numbers that are bigger than 2, but is 2 counted in this problem? Is it part of the answers? No, because this doesn't have an equal to mark. So that means it's not counted. So on the interval notation, if we're going to have the smallest answer is just past 2, we're going to put a parenthesis and then the number 2. On the graph, we're going to do the same thing. We want the numbers that are bigger than 2. So I'm going to put my parenthesis on here, and it's going to face, it's kind of opening to the right, like that. And it's all the numbers that are bigger than 2. So I'm going this direction. So I'm just coloring in a little darker arrow on that line. And it goes out to positive infinity. So on my interval notation, I'm going to put to infinity and then a parenthesis there on the infinity. Remember, anytime you're using a positive or a negative infinity, you're always going to use a parenthesis because it can never really get there. Okay, so the interval and the graph look the same. You've got the parenthesis. If you include it, you're going to have an equal to mark on that, and you'll put a square bracket on both of those. So that's the 3 different forms of the answers for that particular type of problem. Let's do another one similar to that. So we negative 3x plus 5 is greater than or equal to negative 7. Get x by itself, so we're going to subtract 5. Negative 3x is greater than or equal to negative 12. And then I would divide by negative 3. I divided by a negative, so that means I've got to flip this symbol around to be x is less than or equal to. And then negative 12 divided by negative 3 would be positive 4. Set notation. All x's, straight up and down bar, as long as x is less than or equal to 4. Straight up, just copy the inequality down. That's set notation is the easiest one. Okay. Interval notation. The smallest number Well, it says all the x's are less than or equal to 4. So that means it's going to go less. So that'd be negative infinity. And then it's going to go all the way to 4. And 4 is going to be included. So we're going to use a square bracket to include the 4. On the number line, I'm going to do the same thing. I'm going to put a square bracket on the 4, but it's going to open to the left because I'm going less than. Oops. So the graph got the square bracket on it, going to the left. You may have seen in math classes before, instead of using the bracket in parentheses, you may have seen using an open circle for a parenthesis and a closed circle for a bracket. Those mean the same things, but this particular, most of your college textbooks are going to use the parenthesis and the bracket instead of open circle, filled in circle out of that. So you may be familiar with open circles and filled in circles. Brackets and parentheses mean the same things. Okay. All right. Let's do one that's a little tougher. Got variables on both sides. 4 minus 3x is less than or equal to 7 plus 2x. All right. So same idea as solving an equation. You want to get x by itself. One of the rules of thumbs that I usually use for inequalities, though, is I try to get all my x's to the left because it makes it much easier to graph. So instead of moving the 3x over here with the 2x, I'm going to move the 2x to the left. And that'll help me when it comes to graphing it later on. All right. All right. Now, I'm going to subtract 4 to get the like terms together. And that's going to leave us negative 5x less than or equal to 3. And then the last step is to divide by the negative 5. And because I'm dividing by a negative, I got to flip my symbol around. Okay. So I got a fraction for an answer. That's okay. It's okay to have fraction as an answer. Set notation. All x's as long as x is greater than or equal to negative 3/5. Interval notation. Greater than or equal to, so that means I'm going to start at negative 3/5 and go to infinity. The graph, I'll show you how to do the fractions on the graph. Easiest way to do that is actually put the fraction in the middle that's in your answers, and then change the numerator on the top. So when you go left, it'll be negative 4/5, negative 5/5, or negative 1. This would be negative 2/5, negative 1/5, 0. So put the one you need in the middle, and then just change the numerator. Don't change the denominator. Makes it a lot easier to do. So I'm going to put a square bracket, opening to the right, and going to the right with my arrow. Shading or arrow, whichever way you want to describe that. What you're doing there. Again, square bracket means we're including that. You're going to have a square bracket if you have an equal to mark. Oh, a parenthesis if you don't have the equal to mark. All right. Next one is what's called a compound inequality. And that's one where you have two inequalities built together. Two inequalities built together in like a sandwich there. Okay. So when we're dealing with inequalities like this, we've got to get x by itself, but we want x to be in the middle of that. So we want to treat this like it's got three sides. You got a left side, a middle, and a right side. Okay. So whatever we do to the middle, we got to do to both of the ends. Okay. So we think, okay, if I just covered up this, how would I solve that equation or that inequality? What would be the first step? Be subtract 5, right? Okay. So I'm going to do that. I'm going to subtract 5, but I'm not going to just do it to the 20. I'm going to subtract 5 from all three places. Okay. So getting x by itself, but you're trying to get x by itself in the middle. Okay. And then that's going to give us -7 less than 3x less than the 15. Okay. And then next step would be divide by 3. So if I divide the middle by 3, I got to divide everybody else by 3. There's x by itself in the middle. The left side doesn't work out real nice. It's just going to leave the fraction -7/3. The right side, 15/3. Well, that'll reduce. 3 goes into 15 5 times. So I'm going to change that to a 5 because it worked out. Okay. Set notation, it's exactly the same thing. The idea is, you're just going to take that inequality, all x's, as long as x is between -7/3 and 5. If you think about interval notation, it's the same idea. Both of those are plain inequality symbols, no equal to mark. So it's going to be parentheses, -7/3, comma, 5, parentheses. Okay. So it's just, all that says is the answers are between -7/3 and 5. That's what that sandwiched inequality says. The graph is not much harder. Okay. Because it's a mix of fractions and regular numbers, what I would do is I would draw me a number line. I know 5 is here, 6, 4, 3, 2, 1, 0, -1, -2. I need my line to be just a shade longer. Get a -3 there. Doesn't have to be beautiful. Now, where is -7/3? I know where 5 is. I can put my parenthesis right there. -7/3. If I do that with the calculator, it's -2.3 repeating. So on the number line, that's a little bit past -2, a third of the way. So it's right there. It's between -2 and -3. -2.3 is about right there. So we're just getting an estimate as to where it's at. Doesn't have to be perfect. Nobody's going to get out a ruler and check it. Okay, just get close. Okay, and then the answers are in between. Okay. So compound inequality there with the answers in the middle. Doesn't get much more difficult than that. Really doesn't. Pretty easy thing. So problems that I would suggest for these two sections, the 2.6 that we talked about earlier, grab that paper real quick, or excuse me, 2.5, 2.6 is on page 226. That's where that came from. 1 through 51, odd, And then the section 1.7, I think, is 145, 1 through 37 on those. So you just some practice for those types of problems, and that finishes up our basic linear equation solving and inequality solving and writing equations of lines that we're doing here. So let's take us about a 10